Okay, so you brought your seasickness tablets, right? Okay, good. Hello, testing. Hello. Yeah, okay. Okay.
It's probably worthwhile starting a minute or two later.
Yeah. No, my plan at this point is to attempt to tell a few jokes and play a few videos and whatnots. Actually, I know what I'm going to do. I'm going to play some video. I'm going to go on YouTube and play some videos and see what comes. Given this is logged in as harness, see what comes up on the recommended list.
Just be aware that you shouldn't be recording the YouTube videos for copyright purposes.
That's okay. This is by the US government, so it's public domain.
Okay, then. Yep, better.
Thought of that one. So just to give you some an example of some of the stuff that I've worked on in the past. Yeah, this one's funny.
Grammarly
not so funny.
does
What, you
more
don't have
than
YouTube
catch
Prime?
errors. With Grammarly,
I'm not logged into the browser. It's not me doing it, so, you know. And no, I don't have YouTube.
Whoops, that wasn't it. Whoops, try to turn. Nope, not going to happen. Whoops. Oh dear. Ow. Oh, this was good fun.
So which one of these are your one-offs?
Okay, so so what you just we're just doing a little bit of a off-the-cuff thing while we wait for more people to show up. What you just saw there was a compilation of the most epic failures from the DARPA Robotics Challenge from a few years ago. So this was a challenge. So DARPA is the U.S. Defense Advanced Research Projects Agency. They invent little things like the internet, the Saturn V rocket, stuff like that. Anyway, they had a challenge for developing humanoid robots that would be able to perform various tasks that would have been really handy to be able to perform by a robot during the first 24 hours after the Fukushima Daiichi nuclear power plant disaster. And so that was what you saw there was some footage from the finals. I was actually one of the team from the US National Institute of Standards and Technology that developed a lot of the challenges, at least for the trials from the DARPA Robotics Challenge. One of the things that's a little bit interesting, the topic of today's talk is well, this little bit here. So this is a robot that was built by Boston Dynamics. The robot was one of the standard robots issued to several of the teams, including MIT that you see here. And the issue that they had was that the tasks at this point involved transitioning from the robot driving a vehicle to the robot getting out of the vehicle and then opening that door and going through the door. Okay, so if you think about trying to get out of a car and all that, it's actually not that trivial of a problem, right? You've got to kind of coordinate several things, this, that, and the others. So what they did is they actually had separate controllers. They had one controller that was being used to drive the car, which knew that the robot was in this position. It was holding onto the car. He was holding onto the steering wheel. It was activating the pedals. And that was being driven by a sort of standard steering wheel and pedal type of controller, sort of game controller-y type thing. And then they had a second controller that was to use to actually get out of the car and actually control the robot as a humanoid robot walking around and doing stuff. Now, what actually went wrong there is, so who here knows Linux, has messed around in Linux? Okay, you know what a daemon is? Okay, and you know that you can have daemons that stick around that control various peripherals. So they had a daemon that was controlling the foot pedal and steering wheel controller that was controlling the accelerator pedal. And when they switched from driving to getting out of the car mode, they were supposed to disable that daemon. They didn't. And so when they were packing up the accelerator pedals and the steering wheel to get out of the way, when they were moving on to the rest of it, someone hit the accelerator pedal by accident. It shouldn't have mattered. The daemon should have been shut down. It should have been ignoring it. It didn't. The foot sensors got conflicting commands, one from the driving daemon, one from the next one, which it had switched to, which caused that shaking that you saw. The really cool bit is that they should have been able to deal with that, because the rest of the controller could deal with these changes in set point. They just assumed that the actuator's gone funny and compensate for it. So it was actually still staying up. It was just trying to figure out how to get back up again when the tail of the robot hit the seat. And it's got no, unlike us, where if we hit something, we can kind of feel it. The robot couldn't feel that. The feet came off the ground, or the controllers went to heck, and the thing fell over. Why is this interesting from the point of view of explainable AI? Well, what did I just give you? I gave you an explanation, right? Because the team was able to. The team wrote the code. The team designed everything. The team did an analysis of what went wrong, and the report that we got out of that was that that's what had happened. Which of course means that you can fix the problem. And the other thing is, you kind of, when you get an explanation like that, you trust that it's the explanation, right? You trust that this is the actual reason why the robot did this and not something else. Because after all, you could come up with any number of explanations for why the robot did that. Yeah? Which one's actually the useful explanation? The one that's, well, it depends on your audience, right? If your audience is a bunch of YouTube fans, well, anything vaguely plausible works, yeah? If your explanation is for your sponsors, you kind of want to give them the real answer. Most of the time. What happens if this was all done in deep learning? You'd be much harder for us to figure that out. Anyway, that's the crux of my talk, so we're done. Goodbye. We're looking fairly full. Shall we start?
I think it's a good idea, yeah.
Okay, well, let me get rid of that and switch to that, because that's actually my thing.
Okay, and
Okay.
Let me take over briefly. Thank you all for turning up here. It's we've still got people coming in.
There's still people coming in. That's okay.
Initially, I was thinking we might get 20 or so people. As you can see, we've got a little bit more than that.
Not really. We've only got 20 people here, surely. I mean, we've got the repeating hologram projector going, right?
Explain that to me later, yeah.
Yes.
Anyway, so this seminar is going to have Raymond here talk about one of his very favourite topics that you've already heard him talk about a bit. It's really good that you've come along here, because I don't know how much time we're going to have to get Raymond to talk about that in future, since he's not often actually in the country. As you know, Raymond is, well, as you hopefully know, Raymond is and has been our main robotics person, and you've probably seen him on Open Day and a bunch of other places. He's interested in both the hardware, but also the software, the artificial intelligence behind it, which is really useful, and does all sorts of cool things like work with the people going into Fukushima and whatever. Raymond very kindly agreed to do this seminar for us. It's hosted by Curtin, of course, and organised and sponsored by the IEEE Computer Society. So thank you all for attending. I probably should have mentioned a whole bunch of titles and official things, but I'll just let you get on with your talk.
Okay, thank you. Thank you, Hannes. And I'd like to start by acknowledging the traditional owners of the land on which we meet, the Woodjack people of the Noongar Nation, and pay our respects to their elders past, present and emerging. So, explainable AI. So, who here? So, just if I can get a show of hands now that you've sort of been able to wake up a little, who here has actually come from the AMI, the machine learning, advanced machine intelligence unit? No one. A few nervous hands. Come on, I'm not teaching that unit, so it's. You are, yeah, okay. Okay, so, well, it's so great to see so many people here. This is a topic that is very near and dear to my heart. So, I'm was, I guess, a senior lecturer here at Curtin University. But my main research interest is in trusted autonomous systems. That is, how you can get autonomous systems, be it robots like some of you saw in the preview video, but this also includes things like cyber-physical systems, power grids, smart industrial plants, smart buildings, not so smart buildings, driverless cars with drivers in them, all that kind of fun stuff. And two of my focus areas, one of them is on testing robot capabilities, that is, can we trust them to have the capability to do what they or their makers claim they can do, and the other one is in explainable artificial intelligence. That is, can we have some trust in their decision-making capabilities? And on this particular part of it, we're working closely with both the University of New South Wales, and through them the Defence Science Technology Group, formerly DSTO, as well as the US Naval Research Laboratory. So why do we care? The case for explainable AI. So there's another DARPA connection, and that is DARPA, US Defence Advanced Research Projects Agency, actually has a whole program on this because they kind of want to know what they're doing. The idea is that explainable AI will be essential if users are to understand, appropriately trust, and effectively manage this incoming generation of artificially intelligent partners. Who here has heard of deep learning? Okay. Who here understands deep learning? Okay. Well, the problem we have at the moment is, and this is predominantly deep learning, bear in mind that deep learning isn't all of AI or machine learning, there's lots of other things. But today, the predominant sort of deep learning approach involves getting a bunch of training data, having some kind of learning process, you get some kind of learned function saying this is a cat, it outputs the probability this is a cat, and the user has a task which is figure out where all the cats are. And you kind of have these questions that you can ask, but you're not going to get an answer to, right? Why did you do that? Why not something else? Why, when do you succeed? When do you fail? When can I trust you? And how do I correct an error? Now, clearly, if you're looking for pictures of cats on the internet, you kind of don't really care, right? If you're trying to figure out, should I show this advertisement or that advertisement to the next user, you also don't really care. If you're trying to schedule the NPCs on a first-person shooter and you're trying to figure out, do I go through this door or that door, you don't care. There are lots of areas where you do care, right? You do care if it's a medical diagnosis. You do care if it's an industrial optimization, and instead of the system changing a parameter and giving you a 20% output boost, it ends up giving you a 50% decrease in output, and you want to know why. Okay? So what we as a community, as an explainable AI community, and DARPA in particular, is trying to move to is this kind of approach where you have training data, you have some kind of new learning process, you have an explainable model, you have some kind of interface that gives you an explanation in a way that is human intelligible, and you can actually have, instead of having this one-way communication between your system and the user saying, here is the answer, and that's it, being able to carry on some kind of dialogue with the user so that they understand why not, they understand when you'll succeed, when you'll fail, when to trust you and why you erred. I would argue that they also need to have answers such as, I can see how you came to your decision, I know how to fix you, I can learn something from you, and I feel comfortable around you. Okay? The last two often get forgotten among practitioners of artificial intelligence If nothing else, that also tends to be the topic of a lot of science fiction. You know, up until now, the history of automation has been the human, you know, fills a whiteboard full of math or a simulator or whatever. You know, who here has had fun with Simulink or MATLAB or all that fun stuff? And so, you know, you've kind of got to figure out the control laws or whatever's, maybe with a bit of help from simulation or whatnot. And then you tell the computer, okay, this is what the plant looks like, this is what the plant does, these are the control laws in force, here's how I want you to optimize, okay, go do. Wouldn't it be kind of nice for the system to occasionally come back at you and say, hey, I found this really cool property about myself. Look, I can optimize myself another 10%. But here are the numbers going into the control laws, so you can check them for me. Because, of course, you know, for those of you here who know system identification and all that control modeling stuff, there are an awful lot of assumptions you need to make just to keep things tractable. So that's the goal. How do we do this? Now, of course, as I mentioned, you know, different applications have different users and different explanations. Explainability is just one of the many factors that you need to think about. I gave you a bit of a preview. Some applications you don't care. Okay, I'll take the extra 3% of predictive accuracy in my ad targeting, you know, in exchange for not having it explainable, because you know that could be an extra, you know, 5, 6, 10, $20 million. Whereas if you're dealing with surgery or something like that, you care a little more. The result of this, and the reason why this hasn't, one of the reasons I believe why this hasn't been taken up as much as it should have, is because everyone uses different terminology. And the reason why I want to talk to you about this today isn't just to impress on you that this is important regardless of whether you're a developer, a manager, or someone who's vaguely interested in this sort of whole AI thing. But to be aware that people will be talking across purposes and people will be using different terminology, and that terminology won't always be consistent. A lot of this actually comes from my work on standard testing for robots, where one of the big challenges was getting everyone on the same page. At that point I was talking about, you know, say robots climbing stairs. Everyone says they can climb stairs. Well, yes, but everyone climbs different stairs. How do we stop people from talking past each other and having a set of standards to go on? So that's what we're trying to develop here for explainability. Now, of course, the other reason why this is important, who here knows about the General Data Protection Regulation, GDPR? A few hands going up, okay? I know there's a few industry hands going up in particular. Came into force last year in May, mostly about the handling of private data, but one of the things that it kind of theoretically has, although some legal practitioners are making arguments that it doesn't actually say this, is it enshrines the European citizens' right to an explanation. What it means is, as a company you know, makes a decision on my insurance premium, I have a right to go to the company and say, what was the decision process by which you made this, you know, you decided on my premium. Now, I'm not a lawyer. My understanding of the reason for this is because there are certain properties that companies aren't allowed to use to make these decisions, right? You know, a company isn't allowed to turn down my insurance coverage on the basis of my race, for example. Furthermore, the insurance company isn't allowed to reconstitute a variable that is closely correlated with race and then use that to make a decision on my insurance, right? What's deep learning really, really, really good at? A few laughs, yeah? Reconstituting variables if they're useful. Yeah? Okay? A few, I remember going to conferences like ICML and ICHCAI, and you know, there were whole sessions on GDPR and machine learning and some fairly nervous people. This is back before May last year, sort of going, yeah. What does this mean? What does this mean for our business model? I actually don't know what it means for your business model because I'm not a lawyer. I'd be nervous. So how did I get started in all this? Well, this is my PhD. I finished this in 2009, a long time ago. Oh, God, goodness, that's 10 years ago. I'm old. Anyway, it was to, and my PhD was on an area, so who here knows learning by imitation? Okay, basically you do something and the robot looks at what you do and tries to imitate it and learns from it. I was working on a branch of learning by imitation called behavioural cloning. Behavioural cloning is a bit different to other forms of machine learning. It comes out of a topic called expert systems. Who knows about expert systems? Okay. Expert systems is actually less about making a decision and more about encoding knowledge. Right? The fact that you can play this knowledge back and get a decision out of it is almost a side effect. Behavioural cloning involves observing what a human expert does and trying to derive a model in a form that represents human intelligible knowledge that explains what the human does. Why do you think we need this? Well, have you ever asked yourself, why did I turn left there? And try to come up with the real explanation? You kind of can't, right? Here's the reason. Now, I'm going to play fast and loose with the terminology. Those of you with psychology backgrounds, don't shoot me. But when you practice something, you're using the conscious mind to program the subconscious mind, right? By the time you have a task down that requires practice, that requires gut feeling, that requires you to do something without thinking about it, you're programming a part of your brain that is unavailable to introspection. The human mind is a black box. We found this in the expert system community when we were asking experts to explain their decisions, be it medical or industrial optimization or whatever the case may be. And we were finding that when we played back policies derived from the human's explanation, those policies weren't following what the humans were doing. Right? There was always an exception. There was always something that the humans were doing that was different to what they said they were doing. Kind of makes some sense, right? You try this as an experiment sometime. Next time you're driving a car, think, okay, how many degrees am I going to turn the steering wheel in 3 seconds? And you kind of can't, you just do it. So behavioural cloning was developed as a way of trying to develop these, trying to find these rules, trying to explain what the human was actually doing. And often it could actually do an even better job than the human due to something called the cleanup effect, right? The human doesn't behave consistently. But if the human can do the same thing most of the time, sometimes the machine learning could actually kind of ignore the mistakes that the human makes, especially if it then also sees the consequence. And you can actually end up with a policy that performs better than the human and can explain what the human's doing. Or at least, can it give you one of the explanations for what the human is doing. So in our case, this was a robot driving over rough terrain. You look at this is the feedback, 3D images and whatnot, and you end up with a decision tree, right? Who here knows decision trees? Yeah, we're all fans of decision trees. This has actually been heavily pruned, so it would fit on a slide without a magnifying glass. The real ones were going for 5, 6, 10 pages. But you can explain this, right? You can, if you want to get that node, that's kind of what it unrolls to, right? You can have this kind of dialogue with the robot. I have decided to drive forward and to the right. Well, why did you do that? Blah, 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 blah. You can have this kind of dialogue. But what's more, you can also have well, wait a minute, that sounds wrong. You can say, well, the most likely, what is the next most likely action? Next most likely action is drive forward. And as a human, you're thinking, I would have driven forward. Why aren't you driving forward? And then it can actually go and show you the training data that gave you this discrepancy. And then you can say, oh, okay, I didn't notice that. The system can either teach you something, or you can say, that's funny, that shouldn't have made a difference. Okay, where was all that training data gathered? Oh, that training data was all gathered last Thursday. Huh, that's right, I had to recalibrate the sensor on Friday because I found it was out of calibration. right? Blame assignment. Figuring out where the mistake came from is kind of important. Look at the headaches that Boeing is going through at the moment, right? Going back to first principles, tracing why something happened. Another example, a medical diagnosis. Okay, in this case, your tests are expensive, right? As a practitioner, you don't want to order all of the tests, all of the things. Well, we can use the same systems to incrementally say, well, okay, I know this amount of data. Which next test should I order to give you a more confident solution? And more importantly, why is this test interesting? So now, of course, you go into any deep learning, machine learning conference and whatnot, and you talk to the various practitioners of the various disciplines there, and they'll all say, oh yes, my system is explainable. Explainability is kind of fashionable at the moment. The problem is that there are many, many different types of explanations. We've already talked about two of them right now, right? We've talked about the explanation, the actual reason why the system did something, and we talked about an explanation, something that fits what you observe but doesn't necessarily match the reason. So I proposed another rough characterization for explanations. Now, those of you here, especially those of you who have a HCI or HSI, human system interaction background, will also know that there are other categorizations for explanation that cater more towards how well an explanation is received, what the likelihood that someone will understand it, all that. Okay, so I'm not talking about that categorization because we already have those. I'm talking about a categorization for the information itself, not the presentation. I'll go into these in a little more detail. Understanding the detail isn't so important as it is to understand the reasons why these are different. So when you go out and you encounter a machine learning system and they say, yes, this is explainable, you can, in your own mind, make your own requirements analysis and figure out, is it explainable in the right way for my application? Conversely, when you're going out and you're selling your system, you can express it in a way that makes it unambiguous, the types of explanations that your system is able to produce. So the first one we already talked about, source versus, so the source of the explanation. Is it the explanation? We call an introspective explanation. You're introspecting into the decision-making process and coming up with an explanation, the white box or the transparent box approach, versus what we call a post hoc rationalization. This is an explanation. It's something that fits. I sometimes use the term explanation linearization, right? Or explanation function fitting. You know that if you have n data points, you can fit an infinite number of polynomials of order n plus 1 or greater to those points. Yeah, right. It's just like for any set of decisions, there are an infinite number of explanations that will fit, right? Yeah? I mean, some of them are nonsense, but a lot of them sound very plausible, and that's where the danger is, and there's significant middle ground. So what's an example of this? So, for example, and I'm going to borrow some slides from DARPA, these is what some people are doing with their neural networks, right? You say, this is a man in a jacket standing at a slot machine, and actually, at a point, this is an introspective explanation, right? Because it is coming from the actual neural network excitations, right? The convolutional neural network can tell you, I looked at these bits of the image. Or you end up doing some kind of ablative thing where you block out bits of the image and you figure out what affects the classification, and from there you can infer that the system has to have looked at these bits of the image, because when you get rid of those bits of the image, it doesn't work. Much as I rant and rave on about deep learning does give you some form of introspective explanation. Whereas you have other types of, oopsie daisy, let's see. So this is actual tracing of the path. What's the problem with this, though, of course, is once you get beyond trying to figure out which bit of the image you're looking at, things start getting unintelligible fairly quickly. What's an example of an ad hoc rationalization? Well, I gave you one before, right? The whole looking at what the human does and trying to explain what they do. Well, you're not really necessarily explaining exactly why the human did what they did. You're coming up with the most likely explanation. And if you're using something like, decision trees, for example, you're applying some kind of inductive bias to the decision-making process, such as looking at one parameter at a time. There's actually an awful lot of work in learning to explain, where you try and learn a neural network that not only makes decisions but also explains them. And there you have some sort of halfway properties, because they're still using features that have been derived from other layers of the network, but the explanation it learns isn't necessarily hooked into the nodes that are actually doing the decision making. So there is some fuzziness in there. Is that good enough? Depends on your application, but it's a question that needs to be asked. The next parameter that we like to talk about for explanations is the depth. By this I mean how far back into the decision-making process do we want the explanation to give us. For example, the previous example where we had, this is a man standing in front of a slot machine, and this is the region of the image I looked at, which told me that this was a machine or a slot machine, is an attribute identity explanation. It tells you which attributes, which bits of the model were important. That might be all we need. But what happens if we need to know what was it about those bits of the image that told you this was a machine? That's a much harder question, right? That's an attribute use explanation. These are the decision boundaries of the attributes in that decision. And then you can back that back to the model explanation. Why were these bits of the picture interesting in telling the difference between this being a machine and this being a something else? You've got no way of figuring that out for a lot of these machine learning techniques, right? But if you have an error, if the system is giving you something wrong and it's saying this is a machine and it's gone off and highlighted some random thing in the corner, you kind of want to be able to point to that bit in the corner and say, hang about, why was this bit over here interesting? Potentially with an eye towards fixing the problem or learning something about this problem that you may not have been aware of. Okay, everyone. So people have heard of the example of the neural network that could tell huskies from other dog breeds really, really well because it was looking at the snow in the background. Yeah. Stuff like that. Okay. The third parameter, the third sort of dimension we like to talk about is that of scope. That is, are we just trying to explain a single set of decisions or a single decision, or are we trying to teach the user something? Teach the user. That user could be an AI expert or a domain expert or a general user or a member of the lay public or a regulator or an investigator. And each of these users will have a different requirement on what this means. Now, DARPA actually has a whole thing about this when you start talking about going beyond a single decision explanation, right? And this is all about, again, do you trust the system? Do you trust that your mental model of the system is correct? Do you have some kind of, so the whole idea behind the explanation from the system is that it revises the user's mental model, and as a result, the team of the robot or the system and the user achieves better performance that you can then test. This also actually introduces a somewhat interesting workaround for a lot of this, and that is the trade-off between explainability and explicability. Who here is familiar with the term explicability? No one? Yes. Okay. Well, okay, but you all heard of the term inexplicable, right? Okay? So something is explicable if it does something that you expect. If it does something that you expect given what you think it knows, you're less likely to ask questions and you're more likely to trust it. Right? Yeah? Okay? I'm standing up here, I am talking to you from up in front. This is explicable. You've come to a talk, this is what you expect, right? If I sort of turned around and just kept talking at the wall, that's inexplicable. You'd be thinking, why is he doing that? Yeah? Okay? So, part of this goes two ways, right? Explicability involves having some understanding of the user's mental model, right? I have an understanding of your mental model. You've come here for a talk, you expect someone to talk to you, right? And so I do something that is explicable, which means that you trust me, which means that you don't ask me what the heck I'm doing, right? So, how do these relate to specific techniques and applications? So, coming back to this, now that we have this terminology, well, what kinds of explanations do we care about? Well, if we're talking about a robot here whose job it is to water grandma's plants, and Grandma asks, why haven't you watered the petunias yet? Do you really care to give the full explanation as to why the petunias didn't need watering just now? Well, no, you've got a different job ahead of you, right? You're not necessarily coming up with the explanation. You want an explanation, but now you want an explanation that makes sense to Grandma, that is going to result in an appropriate action, and that also possibly flags something to say, hey, Grandma questioned what I was doing. Hey, can someone who may have some more background knowledge just double check that I'm doing the right thing, right? You're not necessarily rushing headlong into the explanation. What about the self-driving car? Right, we've got Waymo up there, but you've got Tesla, you've got Bosch, you've got Mercedes, you've got Toyota, you've got any number of companies all diving into self-driving cars. So the self-driving car decides to change lanes and the passenger goes, huh? Okay, you don't have much time for an explanation there, do you? Right? Who here has actually driven a car with assistive features, adaptive cruise control and all that fun stuff? Yeah, so those things are already giving you explanations, right? So if you've ever driven, say, the Subaru eyesight system and you put your hand in front of one of the sensors and the system goes ding at you and says, I can't, I'm sorry, Dave, I can't do that because, one of the sensors is blocked. It's an explanation. Of course, then sometimes that gets it wrong. I was driving in Washington, D.C. earlier this year, driving a car with a radar that kept distance. I wasn't paying as much attention as I should have, and I only found out because I was really close on the highway to another car. Turns out the radar had iced over. And it took about 5 more minutes down the road before the system popped up and said, hey, I can't keep distance anymore because you need to clean the sensor. Yeah. Not that useful an explanation because the system was able to give an explanation, but the parameters around it giving the explanation weren't set up correctly and it lost effectiveness before it decided to give the driver an explanation. Whereas if the user of the explanation is a coroner because there's been an accident, you kind of want the in-depth, this is exactly the reason why this decision was made. Because guess what? You get the argument that humans don't give explanations, or at least they don't give the explanation for the reasons I just outlined, and society works. Why should we expect the same of the systems? Well, guess what? Society is designed to deal with this, right? We take out all of the correlated failure modes, or we control them as much as we can. We have safety standards in our roads. We have safety standards in our cars. We have driver training. We have penalties for not following the road rules. In general, if a human crashes enough times or whatever, generally the failure mode is that human. You don't care what explanation they give at that point. They lose their license. Problem solved for society, right? Because now your only correlation is the person. That failure mode isn't correlated with all the other drivers on the road. What happens if your self-driving car crashes into too many things? Well, you've now got a fight on your hands to convince society, to convince the regulators, that the other 1,000, 10,000, 100,000, million cousins of this particular car with the same feature set, with the same deep learned model, don't have the same correlated failure mode. If you wanted to do the equivalent, you'd have to revoke that model's license. And that means taking every single car with that manufacturer's model off the road. We've been here before, right? Cars get recalled all the time. Airlines get recalled all the time. You can bet the Boeing 737 MAX 8 isn't flying again until the regulators have had a line-by-line explanation of why the plane fell out of the sky and why it won't happen again. In the future, I think that machine-learned systems in command of equipment that can cause that level of loss of human life, and that includes self-driving cars, should be held to this standard. That presents a challenge. That presents a big challenge, especially to all of you who are going off and building these systems, who are going to be using machine learning. This actually plays into one of my biggest fears, and actually my sort of career goal in the midterm, my goal in life. My goal in life is to avert the next AI winter. Because I think that AI winter is going to be caused by exactly that. It's going to be caused by machine learning, deep learning being used in inappropriate places. It's going to kill a few too many people, and the regulators are going to come down and say no more machine learning in all these applications, losing sight of the fact that machine learning and deep learning aren't the same thing. Right? So it's all up to all of you to help me avert this. Yeah? Okay? Educate the people that there are alternatives to black boxes. And you can, of course, imagine the same thing with medical. You can imagine the same thing on Mars, right? You kind of have a very, very high value asset there. You kind of want to know what it's going to do and why. Okay? And of course, I've already talked about these specifically. So that is basically it for the prepared bit. I wanted to leave plenty of time for questions. I know there'll be plenty. There's always the one deep learning person in the room who I'm going to be arguing with. If not, I'm sure Hannes will be more than happy to play that role. But yeah. Any questions? And I welcome questions not just from the machine learning practitioners or the machine learning students. I gather we have some people from the rest of academia and from industry here, possibly from the general public. What do you think? What would you like to know? And would you like to sign up with me to help avert the next AI winter? And along with it, avert the next robot apocalypse? Because, of course, if we know what the robots are thinking, we can stop them.
So then, when you say the next robot apocalypse?
Yes. I'm sorry?
You're saying the next robot apocalypse?
Yeah. We've already averted one of them.
Oh, good.
You just don't remember. No one? Questions? Yes.
I know it wasn't mentioned, but I'm just wondering where genetic algorithms fit in with machine learning.
Okay, so the question there was where do genetic algorithms fit in with this? So I must admit I've been picking on deep learning because deep learning has been the sort of flavour of the month. And for good reason, right? Deep learning does pretty well. It can model things very well that a lot of other things can't do. It achieves some incredible accuracy levels. Genetic algorithms I'd put in the same box because genetic algorithms don't actually generate knowledge as such, right? Genetic algorithms do random, effectively perform these random movements in the space it's looking for, random but guided by things that seem to work until it stumbles across the solution. But that's kind of hard to explain, right? It's kind of like trying a bunch of things until something worked. Is it good enough for ad targeting? Sure. Is it good enough to figure out the treatment for a medical treatment? Maybe. I mean, we do have a lot of throw stuff at the wall and see if it sticks going on. I mean, that's what. I mean, this is why this is why you have so much trial and error going on. This is why there's all these experiments going on. The point is, though, is that that's a question that needs to be asked, and the level of explainability, of traceability, of accountability in genetic algorithms is similar to that of deep learning, and it needs to be used in applications where that's acceptable. Does that answer the question?
I think so, yeah.
Okay.
Thank you.
No worries. Yes?
You gave that example of a flower watering robot and having to create a response to the grandmother's question.
Yes.
I suppose
Or grandfathers. We're not being gender specific here. The grandparents. Yes.
Yeah. I suppose that problem of having to understand the context of the question and prepare a response based on the evidence, I suppose that's kind of its whole other layer in addition to it actually achieving its job of maintaining
Yes.
the garden.
Yes.
How do you see the creation of that? Like, can you explain that a bit more?
Okay. So, and part of this actually comes back to, I love Prezi, comes back to this, right? And I am making mass generalizations. There are some very, very smart grandparents out there, trust me. And so, but part of it involves the system having some understanding of the user's mental model, right? And giving an explanation that is consistent with that mental model, right? And the mental model may be something that is being provided by the vendor or by whoever set the robot up. It could be something that is learned, right? It realizes, hey, my day-to-day user is someone who's fairly tech savvy. I can give a more in-depth explanation versus, the person, my day-to-day user. I'm a home care robot. My user's mental capacity is limited. I need to give them an explanation that means that they stop grabbing onto me. Or I need to give them an explanation that keeps them happy and in good spirits, because that's the important thing. And then at that point it then says, okay, I also need to inform this person's carer that I've had this interaction because it may mean something. It may mean that the petunias are actually dying and the robot can't figure it out, for example. It may mean that the person's cat has eaten the petunias or something, I don't know. Maybe the cat's called Garfield or something. Got a few chuckles. People here still would read Garfield? Yeah. Okay, but does that answer the question?
I mean, kind of. I mean, that sounds optimistic in a kind of hypothetical way, but how would you go about actually achieving that? That sounds really kind of futuristic, being able to see the context and see all those different levels of information of all the different individuals and the connections between them.
It does. It is still a topic of research. For the recording, the question was, it seems kind of futuristic for these systems to be able to learn the mental model of the user, so that it can give an explanation that is not only pitched at the right level, but to give actually the right type of explanation, even if that explanation has to go off script. That is a topic of research at the moment, and for that I would have to direct you to the HSI, the Human Factors literature, because I haven't been keeping up to date with that. But there is an awful lot of work there. The likes of Amazon Alexa and Google Home and Siri and so on and so forth are investing in that area as well. That is you're right, it's futuristic insofar as there is research being done. It will be available surprisingly soon, I suspect. Besides, having adaptation for a user's skill level isn't that uncommon anyway. I mean, I understand computer games do that all the time. Finding out the user's level from adaptive testing has been done for years. I mean, I got my my MCSE, Microsoft Certified Systems Engineer, in Windows 2000, and they were doing adaptive testing at that point. So this is a topic that has had a lot of input. MCSE, MCP, something like that. It was a while ago. Any other questions? There's one right at the back.
So can you hear me from here?
Yeah.
So obviously, one thing about AI is sort of is the fact that it can give humans the ability to focus on the more important things, whilst letting kind of machine learning do that for you. Do you think that human thought is at an advanced level enough that we can actually take advantage of being in that situation?
Okay, so the question was that we can get AI systems to basically take some of the load off humans by, by taking over some of the thought, load. And are we kind of up to there from the human side? Is that what you're asking? So this, I think, plays a little bit into the whole, well, are the robots as smart as humans? Right, a little bit. And I'd actually argue that that's a meaningless question, right? I mean, is one human as smart as another human? Well, no, humans have different areas of expertise, right? There are some things that some humans are better at other humans at, and vice versa, just like there are some things that the AI would be better at than others, right? It's a Venn diagram with a very, very incomplete overlap. So I would argue that AI is most interesting not where it overlaps the human, and so where it can take the load off, although that is vaguely interesting, where it overlaps the bits that we don't want to do. It's most interesting where it doesn't overlap where we can do, where it's doing the things that we can't, where it's allowing us to do more than we could in the past, where it's allowing us to make better use of our resources, where it's allowing us to, to have more free time, where it's allowing us to connect with other people in more interesting, more thoughtful, more meaningful ways. Where it's and then where it is taking time to, where it is doing stuff that we could also do, it's taking away the stuff that we're not that interested in doing anyway, right? I mean, this also plays into the robot, the machines are taking our jobs kind of thing, which, is a problem in some areas as well. Is it something that we should be worried too much about? Well, yes. We need to be mindful of the people who are being displaced. We need to be mindful to make sure that we're leveraging the fruits of AI in a way that is meaningful for everyone. But we've been here before, right? When cars came out, it certainly put an awful lot of blacksmiths out of business who were doing horseshoes, right? It put a lot of stable hands out of business. But then new industries sprang up. There's a time of disruption. Whether that disruption and whether the people who were disrupted were being handled well, were being treated well or not is a different question. Is a question that we should be asking ourselves now. But the end result was progress, beyond the dreams of those who started it. So Yeah, that's an important question. Incidentally, for those of you who are interested, there was a discussion paper that closed recently that is still worth a read. This is Artificial Intelligence Australia's Ethics Framework. This discussion paper here doesn't claim to answer all of these questions, or in fact, it doesn't even claim to answer any of these questions. What it does do, though, it does list out the ethics questions that should be asked when it comes to Australian society. The discussion period has closed, but for anyone interested in this, including out in industry, and especially those working in policy and elsewhere, I highly, highly recommend reading it. It is a very readable document. It's not very long, but it poses an awful lot of very interesting questions for anyone who is going to be dealing in AI, and I would argue that in today's society that is everyone. Does that answer that question plus a bit more? Cool. There was a question in front here. Yes?
Yeah, so I'm not a massive fan of them, so no major argument here.
I'm sorry, I can't hear you.
I'm not a massive fan of them, so no major argument here, but deep learning systems.
Yes.
They're being applied to all sorts of things because they are quite effective.
Yes.
XAI, as I understand it, deep learning, at least some part of it will defy explanation.
Yes.
So if we want to have a full explanation, are we going to be able to, would you consider we're going to be able to still use deep learning techniques? Are we going to have something that's as capable, or are we going to have to make these trade-offs between explainability and, effectiveness?
Okay, so the question was basically, are we going to have to make a trade-off between explainability and effectiveness, given that deep learning is going to remain largely unexplainable pretty much for the foreseeable future, but yet it is so much more effective than so many of the other solutions that we have? So my argument there is it's all about taking a nuanced approach to where you need the explanation. You may not care about the explanation for the low-level feature detection because because that is a well-defined, bounded problem. You can test that to statistical significance. You can do deep learning there and then test the heck out of it and be okay, for example. And then for the layers above, where you get more specialized, so you have less data, it's doing more interpolation, it's doing more extrapolation, because one of the problems with deep learning is very hard to figure out how it's extrapolating beyond what data it's seen, whereas a lot of these other techniques, you have some well-defined ways of extrapolating. And wrapping that on the higher level, that might be a solution. You might have solutions that involve using deep learning to model within a particular area of space, of your state space, and then using that to then generate data that is now conducive to doing other forms of learning. You can start having these more sophisticated hybrid systems that can seek to give you a little bit more explainability without costing you too much predictive accuracy. Now, of course, it does lead on to the question. Let's say you had a system that was that gave you, say, 95% predictive accuracy, but when you disagreed with it, you couldn't get an explanation out of it, and you had no idea who was right, as compared to a system that gave you 85% predictive accuracy, but could give you an explanation, the explanation that for when you disagreed with it, you could figure out whether you were right or it was right. Now, who would prefer the explainable solution? Who would prefer the non-explainable solution? Who says it depends? Okay, it's a trick question. It depends on the correlation of the failure modes, right? If the human's failure mode is correlated with the machine's failure mode, the explanation doesn't help you, right? So you'd rather have the greater predictive accuracy. But if you've figured out that in your solution there is a very low degree of correlation between the human's failure mode and the machine's failure mode, well, as an overall system, you might get better performance by accepting the lower predictive accuracy on the system, but where you can get that explanation. It depends. And it requires practitioners of AI who are aware of this trade-off, just like there are trade-offs with amount of training data, with training time, with model size, with all this, that, and the other. There's always trade-offs. It requires managers that understand that there is this trade-off and at the very least give their AI practitioners the leeway to make that trade-off in a way that makes sense. It requires policymakers to enforce that this trade-off should be made before it kills too many people. Right? Does that answer the question? Yeah. Okay. Yes?
To clarify that, so you're saying that in order for us to use explainable AI, we have to legislate against unexplainable AI in some areas? So just say you're not allowed to put this here.
I'm saying that there are many applications where we can rely on the market to do that. There are many applications where we can't. Does that make sense?
Yeah, so you're saying at some level we need to legislate.
So yes, and the question was, do we need to legislate for explainability? And I would argue that oftentimes the short-term market forces probably don't push companies in the direction of long-term sort of public good in that regard. And I mean, it's the same reason why we have safety standards, right? It's the same reason why we have accountability standards. It's the same reason why we have consumer protections. And I'd argue that this is going to be up there with it. And the fact that this document actually talks a lot about explainability is a good sign. That Australia's government is paying attention to this. Did that answer your question? Yeah, there's a question over here. Yeah.
Yes, so there's some situations and tasks that, in order to be explained, require a level of emotion in it.
Yep.
And they're often performed by humans. But if an AI was to perform that task, do you think it's important to have AIs that have the ability to simulate emotion in that explanation, or should that be left to people?
Okay, so the question was, there's some decisions that require some degree of emotion, and does the AI need to simulate this in order to, to make those kinds of decisions, or should it be left to the human? I would suggest that there are two types of answer to this. There are two types of decision making. There's the first type of decision making that does have an emotional component that shouldn't. And for those, I'd argue that no, the AI shouldn't simulate emotion because emotion isn't a good thing when it comes to that. Now, sometimes you get emotion conflated with ethics. Because you're saying, oh, you shouldn't have made that decision. That's the whole trolley problem, right? Who here has looked at the ethical machine sort of thing, right? Should you kill the three people? Should you kill the three people jaywalking, or the one person who's in self-driving car, or all these different scenarios, right? So I would argue that that's not an emotional decision. That's one of understanding the ethics that should be applied. That's an open question that I think is a question that shouldn't be answered by the AI practitioners. That should be one that's answered by society, at large, and there should be an ethical discussion about that, and that may differ from place to place. There are others where you're talking about, like say, home service robots, where you're interacting potentially with a person who may be emotionally frail, where it might be important for them to have some ability to relate to a being that, from their perspective, is explicable, given that they're modelling them as that the agent is having some kind of emotion. In which case, maybe simulating emotion is a good thing. At that point, whether that simulation needs to be the subject of learning, or whether that can be something that's hard-coded, I don't know. So my answer to your question is, it depends. It depends on which element of emotion you're talking about. Does that answer your question? Yes?
You said that the human mind exhibits a black box approach in regards to decision making. But where do we see that same black box approach occurring in machine decision making that doesn't have a causal explanation?
Okay, so the question was, humans have black box decision making, but when do we see machines making decisions that don't have a causal explanation? Is that your question? Okay, so yes, we do. I mean, they're called anything that has a random number generator, right? Is by definition not supposed to be causal. Leaving aside the fact that random number it's actually very hard to get a true cryptographically secure, statistically significant random number out of a computer. I'm seeing nods from people here who are doing cybersecurity. Now, I would argue that yes, and I would actually argue that any machine learning system that requires a random number generator at any point, by definition, can't be fully explainable. Because there is some part of its decision making that can trace back to that random number generator, right? Now, there are some funky jiggery-pokeries you can play by having a random number generator that has a nice distribution but isn't actually random, and you can get some nice mathematical proofs out of those, and that's all fine and dandy. But no, that is a problem when it comes to explainability. There are other systems where the lack of lack of traceability comes from some external factor. At that point, it's important to be able to trace it back to that external factor, some external input or whatever the case may be. But yeah, that is a problem. Does that answer the question? Sort of.
Wouldn't even random number generators have some sort of causal history that we can at some point determine?
Yes, but is that explanation useful?
So is it a matter of just turning explanations that we can, causal histories that we can turn into useful explanations? And that's sort of the approach that we take.
It depends on if the application requires a causal history, and I would hasten to add that most don't, right? But for the mission, life, safety, critical systems, maybe you do require a causal history. And at that point, even if you had a deterministic random number generator, much as that sounds like an oxymoron, that explanation may not be good enough anyway, right? You need to take that out of the system. Does that answer the question?
Yeah.
Okay. Yeah. Any other questions? Yes?
Do you believe the frameworks for explainable AI will be as approachable and publicly accessible as deep learning is at the moment? Like, for example, right now, if you go on my computer, I can download TensorFlow and Python, and I can whip up with some tutorials, a deep learning, model within, an hour. I don't know of anything that exists for explainable AI. What do you think?
It doesn't, and the reason for that is because, and my personal belief into why deep learning has taken off as much as it has, is because the prerequisites for it were made very, very accessible, right? And that includes the compute power behind it, right? You can run up an instance on AWS or Azure, or pick your cloud provider, and off you go. It's also very, very easy to develop algorithms and test them and prove that your algorithm is better than the previous algorithm without ever actually having to touch the real world. That's why there's a lot of research in there, because it's a very, very good way of getting your PhD. It's a very, very good way of getting research funding. It's a very, very good way of getting papers out. Explanations are a bit harder because explanations have to deal with this pesky thing called humans, right? Research into explainable AI, the explanation needs to be evaluated somehow. And you notice that anything that involves dealing with humans is notoriously slow. So will we get these frameworks? Well, not when there's still easy money to be had from getting another X% by running the next lot of, the next lot of whatever training set, or whatever evaluation set comes past. That's where we may need to skew the incentives a little by needing to legislate on some of this stuff. Or needing to have regulations in here that say that if your system isn't explainable, for example, you can't pin the blame on anyone else, then the company is liable for everything that the system does. For example, you need to change the calculus a little. At that point, you might start getting things that are as easy to use. But it's a challenge. Does that answer the question? Yeah. Any more questions? Yes.
Just on ethics in regards to a self-driving car, which inevitably you wouldn't be able to have a self-driving car on the market or on the road without having some programming or decision-making involved where you have the ethical control program.
Yes.
Who makes those decisions and how they sort of get implemented into...
moral machine. Okay, so how do we do this? And what's the? And so I think this is the one. Is this the one? Yeah. Okay. So it's the whole. What would you do? And basically it boils down to who should make this decision, right? Because ultimately the self-driving car needs to make this decision. Now, when it's just human behind the wheel, we all understand that humans making these kinds of decisions at the spur of the moment don't necessarily make the optimal decision. We kind of live with that as a society, and we accept that this kind of situation doesn't happen that often. And the human generally prioritizes saving their own life instinctively, often. And so you might do something else. It's a hard question. And as I sort of alluded to before, that's a question that I don't think should be answered by the AI practitioners alone. That one does require a wider discussion. How are we going to have that wider discussion? I don't know. But that's a broader society. Does that answer the question?
Yeah,
Or,
it makes sense.
Yeah.
I mean, in reality, the likelihood of a scenario where a self-driving car can actually have the computation time to make a decision like that is probably quite low. Someone will walk out in front of you. There's no chance it could do anything else. But just food for thought.
Yeah. Any other questions? Comments? We've all had enough? One at the back. Okay, yes.
You mentioned how humans, when it comes to this situation, we don't necessarily come up with the right decision every time in the case of this past situation. And that it doesn't appear very often, so society just accepts that that's the case. With AI, does that mean we don't necessarily have the needs out of AI that makes the right decision in this scenario? I guess it needs to consider all the ethics of what's going to happen.
So the question there is that we kind of accept as humans we don't always make the right decision every time. Why should we expect the AI system to do the same, right? And again, that's a good question. But humans get hit by cars all the time, sadly. One human gets hit by a self-driving car and it is all over the news, all over the world for weeks. Right? That's just the way things are going to happen. The other thing is, maybe we do have an opportunity to do better than humans. Or at least maybe we can come to some kind of conclusion as a society rather than everyone making this decision, spur of the moment. So.
Isn't it a legal issue more than a moral issue?
Kind of. So there are big chunks of. So the problem with the law is that in a lot of these corner cases, the law isn't actually that black and white. Or if it is black and white, it still needs interpretation. And what happens if it isn't the person who's in control of the vehicle, right? What happens if it is this kind of situation where, the vehicle can't stop in time, right? What does the law say where someone has to die? I mean, what does the law say? The law doesn't. I'm not sure that we know.
Cats on dogs.
Anyway, there's some.
Let's do Windows and Macs now.
Yeah. Anyway, you get the idea, right? So.
Now, there's been lots of questions
Yep.
here. Mark and Valerie have set out some light refreshments just outside.
Yeah, we need to refresh the light. Perfect.
Very good. Are you able to stay out a bit more if people want to ask you individual questions? Maybe you can chat with them.
I guess if it's light refreshments, I'll be staying around for a bite more.
Yeah, there we go.
Okay.
Not a word, just a bite?
Well, I could go for a nibble.
There we go. Okay, well, thank you very much, Raymond. I've certainly had a bit to think about, and I just want to say that I will definitely never outsource anything to AI. Google tells me it's going to take about 11 minutes to get home this time of night. It knows I normally go back, and it reminded me about a few things as well, but I've never outsourced anything.
No, never, no. Here's a good question for you all. Okay, so you have a car. But bear in mind that the car's power steering can break your fingers, the brake can release for you because that's what ABS does, and the cruise control can override your commands. But when you get into the car, you turn on your GPS, so you follow the GPS instructions. But you program the GPS with where you want it to go by looking at your calendar. Who's in control of your car? Is the calendar driving the car through you? Is the GPS driving the car through you? Are you driving the car through the... Yeah. Who's in control? Something to think about.
You can disobey the GPS.
Well, yes. Technically, the GPS can disobey you too. How many times has that happened to you? It's like, wait a minute, I didn't tell the GPS to go there. Why am I showing up here? Okay, anyway, yes, there's food out there and free food, right?
Absolutely. Yes.
Okay, good. That's very good. Thank you. I must have really spoken very convincingly, given you're not all rushing for the doors to get to the free food. You're all students. Come on, what's going on? There you go. Now we have an avalanche.
Thanks, David. That was really good. And it'll be a really good resource for the students.
I hope I didn't say anything too scandalous. I should probably pause this now. There we go. Now it's not recording.